Alright, hi guys. In the previous lesson, we've covered the area of triangle. Okay, so and we've already covered Pythagoras theorem and Torcaso in the previous years. So for today's video, we'll be taking a look at another trigonometric rule. Okay, also known as a sine rule. Okay, so in this video, we'll be talking about the sine rule. Okay, and then in the subsequent videos, we will be looking at the proof as well as the examples that they can ask with regards to sine rule itself. Okay, so let's begin. Now, before we continue, okay, the first thing that you need to recap, okay, is the naming convention of the triangles that we use in trigo rules itself. And that is the fact that the lengths opposite of the angle corresponds to each other. Okay, so if we have angle, if we length A here, the angle opposite here will be A. If we have length B here, then the angle opposite B. And if we have the length C here, then we'll call the angle opposite it C. Okay, so what does the sine rule state? So the sine rule states that if I have the angles and the lengths as mentioned above, okay, the ratios of the angle over the sine rule will be equal to each other. Okay, what this means is that, okay, if I take the length A and the sine A, and we divide it A over sine A, okay, this is equal to, if I take B and divide it by the sine of the angle opposite it, so B over sine B, okay, and if we take the other length C, it's also equal to each other, so C over sine C. All right, so this itself is what we call the sine rule. All right, and the objective of using the sine rule, okay, will be simply to use the sine rule to find either unknown angles and unknown lengths. Okay, and we will go through two different cases where we can apply the sine rule in answering the questions with regards to uh, trigonometry. All right, so this is our sine rule itself. Okay, so just take note that the angles and the length opposite each other always corresponds. All right, so before we continue to the next section, okay, I think it will be good if we can actually take a look at the proof itself. And the proof is actually quite simple. All right, so let's draw the same exact triangle. Okay, and let's call the lengths A, B, and C. So same thing, the angle opposite it will corresponds A, B, and C. All right, so in the previous video, we've talked about finding the area of this whole triangle. So we know for a fact the area of triangle, okay, is given by um, half AB sine C. So that means if we take this particular length, if we take this length and this length, and we take this angle over here, okay, the area of triangle will be given by half AB sine C. Now the thing is, we don't necessarily have to use the A and B over here. We can also use the following length. So we can use also this length here. We can use B, C, and the corresponding angle will be A. So we can actually use this length, uh, this particular length over here. So this will be equals to half BC sine A. Okay, and we can also even use this length over here. Okay, so this will be AC and sine B. Sine B is included angle over here, so this will be equals to half AC sine B. All right. Now, if we divide everything by half ABC, okay, so if we take all these three things over here, okay, and we divide it by half AB BC, we realize that in the first one, the half AB will be cancelled out, so we will have sine C over C. In the second one, we will have BC in half cancel out, so we'll have sine A over A. Okay, and the last one, we will have AC and half cancel out, so we are left with sine B over B. And if we flip everything and rearrange everything, okay, we realize then we can get your A over sine A equals to B over sine B equals to C over sine Z. And that is the proof of sine rule. All right, so this is how we prove sine rule. So in the next video, we'll take a look at examples of how we can um, answer questions with regards to a triangle in trigonometry, and how we can apply sine rule to help us answer the questions. All right.